All right, let's dive into a pretty wild topic. We're going to explore the strange intersection of three huge ideas: quantum physics, artificial intelligence, and meaningful coincidences. Yeah, seriously. We're going to see how these are all connected in ways you probably never expected. And I know what you're thinking. Quantum physics, AI, meaningful coincidence. I mean, how are these even in the same sentence? They feel like they're from completely different planets, right? Well, it turns out they're all tangled together in this incredible web of technology, philosophy, and, well, patterns. So, to really get a handle on this, let's meet the three main players on our stage. First up, you've got quantum mechanics. This is literally the instruction manual for how our physical world works at the tiniest levels. Then there's artificial intelligence, which is, a completely new way of thinking and crunching information. And finally, we have synchronicity. That's that weird, kind of spooky feeling you get when a coincidence feels just too perfect to be random. So, what's the connection? What's the thread that ties all three of these things together? It's the observer. Think about it. In the quantum world, just looking at a particle forces it to snap into a single state. With AI, it's us. We're the observers who train it and then try to make sense of what it spits out. And with synchronicity? Well, that's all about our own mind, the ultimate observer, connecting two random events and deciding, hey, that means something. This idea of the observer, that's the key we're going to use to unlock this whole thing. All right, let's start with the first bridge between these worlds. And this one isn't just theory, it's technology that's being built right now. We're talking about quantum AI. Okay, to get quantum AI, you first have to wrap your head around a concept called superposition. It is absolutely mind-bending. Imagine a tiny particle that isn't just in one spot. Instead, it's in a cloud of all possible spots at the exact same time. It's just a wave of pure potential until you look at it. The second you observe it, bam, it's forced to pick just one location. And that leads us to something even weirder, something Einstein himself called spooky action at a distance. It's called quantum entanglement. You can link two particles together in this special way and then separate them. And it doesn't matter how far apart they are, across the room or across the entire universe. The moment you measure one, the other one instantly knows and changes its state. Einstein hated this idea. He thought it was impossible. But guess what? Experiment after experiment has shown that it's absolutely real. So, how does all this spooky stuff help us build a better AI? Well, think about your computer right now. It runs on bits. A bit is like a light switch. It's either on, a 1, or off, a 0. Simple. But a quantum computer uses something called a qubit. And thanks to that superposition thing we just talked about, a qubit is more like a dimmer switch. It can be a 1, a 0, and every possible value in between, all at the same time. The power that unlocks is just staggering. It can explore millions of possibilities at once. And the potential here, it's almost hard to comprehend. We're talking about things like discovering life-saving drugs because we can simulate molecules perfectly. We're creating revolutionary new materials that we can't even imagine today. We're solving optimization problems that would take the fastest supercomputer we have right now literally billions of years to figure out. And this is a pretty big but. We need to pump the brakes a little. We're not there yet. Not even close. See, right now we're in what scientists call the NISQ era. That stands for Noisy Intermediate Scale Quantum. Basically, it means that today's quantum computers are brilliant, but they're also super fragile. They're noisy, the tiniest vibration or temperature change can mess everything up. They make a ton of errors. So yeah, we are a long, long way from the perfect, all-powerful quantum computers you see in the movies. Okay, so that's the tech bridge. Now let's shift gears and look at our second bridge. This one is way older and a lot more controversial. It's not built out of silicon and wires, it's built out of ideas. Big ideas about how our minds might connect to the physical universe. And this bridge comes from a really unlikely partnership. It was a 26-year collaboration between two absolute giants. On one side, you have Wolfgang Pauli, a Nobel Prize-winning physicist, one of the founders of quantum theory. And on the other, you have Carl Jung, the founder of analytical psychology. It actually started with Pauli as Jung's patient, but it turned into this deep, fascinating exploration of where the mind ends and matter begins. And the core idea they wrestled with was something Jung called synchronicity. You know the feeling. You're just randomly thinking about an old friend you haven't heard from in forever, and literally a minute later, your phone buzzes, and it's them. That's synchronicity. For Jung and Pauli, this felt eerily similar to that spooky action at a distance. They actually wondered, could our minds and the outside world be entangled in some way? Which, of course, brings us to the big question. Is any of this science, or is it just a cool philosophical idea? Well, when it comes to the mainstream scientific community, the answer is pretty clear. Yeah, the overwhelming consensus is that trying to explain consciousness with quantum mechanics just doesn't work. And there are some really solid reasons why. First, it's a scaling problem. The weird quantum rules just don't apply to big, clunky things like a brain. Second, the brain is warm and wet and messy. Any delicate quantum state would just fall apart instantly. That's a process called decoherence. And finally, that whole observer thing, it doesn't have to be a person. Any measurement device at all, even a simple one, does the trick. It doesn't require consciousness. Okay, so let's talk about our third and final bridge. This one brings us right into the here and now because AI is creating a whole new kind of synchronicity. And this isn't some abstract theory, it's something you experience probably every single day. Let me paint a picture for you. You're just going about your day, and out of nowhere, you get this fleeting memory, a random, obscure movie you haven't thought about since you were a kid. And then later that night, you open up your favorite streaming app, and there it is, right on the front page, recommended just for you. That feeling is uncanny, right? It feels exactly like synchronicity. It's like the world read your mind. But here's the twist. Jung's whole idea of synchronicity was powerful because it seemed to have no cause. It was acausal. It felt magical. What AI is doing is different. It's what you might call hypercausal. It's not a mystery. It's the cold, calculated result of an algorithm sifting through mountains of your data, noticing patterns and predicting what you'll think of next, sometimes before you do. And this is so important to remember. The AI has no idea that movie is meaningful to you. It doesn't understand nostalgia or childhood memories. It's just a pattern matching machine. It saw a statistical link. All that feeling of wonder, of meaning, of whoa, that comes from you. We're still the ones creating the meaning. Which brings us to our final, kind of profound question, especially as these algorithms get smarter and smarter. 100 years ago, someone like Jung would experience a meaningful coincidence and ask themselves, is the universe trying to tell me something? Today, we have to ask a different question. Is the universe trying to tell you something? Or is the algorithm just so good at its job that it's designed to make you think the universe is telling you something? And what happens when we can no longer tell the difference?